Hi, my name is Sam Ferrante,
And I'm Mohammed.
and for our final project, we isolated benzocaine using the pH extraction technique. Benzocaine is synthesized using 4-amino-benzoic acid mixed with ethanol and catalyzed with sulfuric acid to produce benzocaine and water.
The synthesis doesn't go to completion, however, but instead we have an equilibrium of products and reactants. This means that benzocaine has to be isolated, which we can do by simply adjusting the pH of the solution. So in order to do this, we put the benzocaine crude product in a centrifuge tube.
The solution left over in the centrifuge tube is made up of benzoic acid, benzocaine, water, ethanol, and sulfuric acid. In order to separate these molecules into two separate layers, we'll need to add dichloromethane. And then shake it up.
As you can see, after shaking and centrifuging, benzocaine is now dissolved in dichloromethane. Because of the entropy of mixing by dissolving benzocaine in the aqueous layer, we still have some benzocaine in the aqueous layer. So what we should do is extract the aqueous layer
Into its own centrifuge tube. There, we will continue washing the solution with dichloromethane in order to remove any leftover benzocaine from the solution. So we will add and mix.
So now we should have a negligible amount of benzocaine in the aqueous layer, which can now be discarded. All we're left with is the organic layer with 4-amino-benzoic acid, which has not been yet deprotonated, benzocaine, and dichloromethane.
After removing the aqueous layer, we'll be left over with only the organic layer, which will include 4-amino-benzoic acid, benzocaine, and dichloromethane. In order to remove 4-amino-benzoic acid from the solution, we will be adding sodium bicarbonate, which will allow the pH of the solution to rise, increasing the basicity, which will allow 4-amino-benzoic acid to be deprotonated and become soluble in the aqueous layer.
Now that we've favored the deprotonation of 4-amino-benzoic acid, it's soluble in the aqueous layer, which we can now extract. So we'll extract the aqueous layer, but in order to ensure that all the 4-amino-benzoic acid has been extracted, we're going to put sodium bicarb one more time, shake it, and then extract the aqueous layer again.
After we've removed the aqueous layer, we will be left over with the organic layer, which includes benzocaine, dichloromethane, and water. We will then proceed with the vacuum filtration in order to remove any leftover impurities. We will be using magnesium sulfate as our drying agent to absorb the water left over in the solution.
Consequently, as we vacuum filtrate, the dichloromethane is so volatile, it'll evaporate out. Thus, we were able to isolate benzocaine and run NMR, GCMS, and FTIR to determine if it was a successful isolation. The results were as follow. Follows?
As follow. I think you were right the first time.
Follows.
As follow. No. The results were as follow. Period. No plural.
Here they were.
Absolutely none.
This is it. Beginning with FTIR, the NH-CH carbonyl ester, CN, methyl, and CH alkane bonds were all reflected in the resulted spectra. No carboxylic acid OH bond was observed, indicating no aminobenzoic acid was present. A CCl bond was observed at 760 wave numbers, indicating dichloromethane had not been entirely evaporated. In total, the FTIR shows that, apart from dichloromethane, benzocaine was isolated. The NMR spectra reflects a less successful isolation. Because of the DCM presence, the electronegative chlorine shifts all peaks towards higher signals. Most hydrogens of benzocaine can be accounted for within a reasonable interval of where they were expected, although in the case of the peak denoted E, the integral and splitting are inaccurate. Peak A might be explained if any sodium bicarbonate was present, though peaks B and C are not so easily explained. No molecule ever in solution has peaks at their chemical shifts, so it might be that the NMR tube was contaminated by previous users, or the large electronegative chlorine atoms caused less shielding for various hydrogen atoms increasing their shifts and creating peaks A, B, and C. In total, the NMR does not reflect an isolated benzocaine. The GCMS reflects a benzocaine peak at 6.1 minutes, with an area percent and purity percent of 17. The ether solvent peak, occurring at 2.8 minutes, has a purity percent of 77. The prominence of the ether indicates very little pure product was introduced to the GCMS tube. What little was introduced, however, was moderately impure because benzocaine made up 17% of the remaining 23% non-solvent species run through GCMS. In the future, less aminobenzoic acid should be used so that the reaction can achieve equilibrium sooner, and the workup would not have to deal with an excess of aminobenzoic acid. Additionally, DCM should be allowed to evaporate for longer. These steps should help produce a purer benzocaine product.
I swear to God, this is why I said we should just start, because I knew it was going to take a lot. Alright.
As you can see, after shaking and centrifuging, benzocaine is now dissolved in the DCM layer. There's no DCM. Isolate benzocaine. I messed that up. Thus we were able to isolate. I'm talking too fast.
The solution left over in the, wait, hang on, what is it called? And we worked up wait. Hi, my name is Sam Ferrante.
And I'm Mohammed.
And for our final project, we isolated benzocaine using the pH extraction technique.